Okay, we're in section 5 of the notes. We certainly continue with the word problems. We covered these word problems. Hopefully it made sense out of what's presented to you. You studied the material and now you feel comfortable about moving forward. We did, simple mixtures. We did uniform motion. That's, distance equals right times time. And then we went through a bunch of examples. I realize that might seem difficult to you. I'll take you up to time with the reading. I'm going to encourage you, though, keep trying. You'll eventually get this stuff. All right, so we did a bunch of examples in class. I'm hoping at this point in time, you're ready to try it on your own, which is the homework. All right, we're going to go to homework now. I'm going to switch to the whiteboard, and the notes are going to disappear. The notes should be in your possession, and we're hoping that you've done the homework by now. All right, so give me 1 second. And I'm going to do a new share with you. Okay, so the notes have disappeared from your screen. And what are you seeing now? You're seeing my whiteboard. All right, so on the whiteboard, what I'm going to do is just go through the problems. And we're in section 5 of the notes. And we're doing the homework. Again, the hope is you've already done the homework. All right, so we'll put number 1 down for you. And certainly, I'm reading it, and it says a coin collection, nickels, dimes, and quarters. I'm going to say coins. It's really a mixture problem. All right, so I'm going to write down what I think it's going to be, and I think we've done a problem like this before, where we have the number of nickels. I'll put this over here. The number of nickels. And next one's going to be the number. Again, you're just reading it. It's got dimes now, right? The number of dimes. Now, this is just me identifying that there's things I don't know. So there's a number of nickels, there's a number of dimes, and there's a number of quarters. Now, what I mean by the number of quarters, I mean there could be 1 quarter, 2 quarters, 3 quarters, so forth and so on. I'm going to read it. It says a collection of coins. I'm sorry, a collection contains nickels, dimes, and quarters. It's a coin collection. It goes on to say there's twice as many dimes as quarters. So I'm going to write this down that and looking at it, the number of dimes is twice the number of quarters. So because I don't know the number of quarters, so I'll say it's X. And this would be 2X. All right, let me read that again to you. There are twice as many dimes as quarters. Well, I got that written down clearly. The number of dimes is twice the number of quarters. Let me keep reading it. And then it goes on and says 5 more nickels than dimes. All right, so the number of nickels, there's 5 more nickels than the number of dimes. Well, how many dimes are there? There's 2X. All right, read that again to you. The coin collection contains nickels, dimes, and quarters. There are twice as many dimes as quarters. Twice as many dimes as quarters. And 5 more nickels than dimes. Okay? The total value is $4.10. I'm going to write that down now. So the total value is $4.10. Now, where's the value coming from? It's coming from nickels. Well, what are nickels worth? Nickels are worth a nickel, which is 5 cents, right? How many nickels are there? 2X plus 5. Okay. There's also dimes. What's a dime worth? 10 cents. How many dimes are there? There's 2X. Last but not least are the quarters. What are quarters worth? 0.25. How many quarters do we have? X. All right, so write this down, 4.10. Hope you're not struggling with this arithmetic, but if you are, you're allowed to use calculators. This is going to be 0.1x 0.05 times 2 is 0.1 plus 0.25. And really 0.05 times 5 is 0.25 plus, well, 0.1 times 2 is 0.2, right? Plus 0.25x. All right, 4, I'm simplifying. I'm going to add the x's together. And what do you get over there? I'm just going to underline it for you. We got this, we got this, and we got this. So let's see, 0.1 plus 0.2 is 0.3. 0.3 plus 0.25 is 0.55. Plus 0.25. Now what am I going to do? I'm done simplifying. I'm going to subtract 0.25 from both sides. Okay, that's what I get on the right side. Now, what are you going to get? You're going to get 385. For students that struggle with arithmetic, you're allowed to use calculators. All right, what I'm going to do now is divide both sides by 0.55. Okay. Again, I'm looking at it. Certainly, if you want to go long division, you can. I'm kind of looking at it, wondering, does it go in? And if I looked at it, let's see, I'm going to say about 7 times, right? So let's put this over. I want to see if it's right, though. So I'm going to say, if I did that, I'm going to say x would turn out to be 7. Well, looking at it, I would say, is that true? Is 7 times 0.55, 385? And that would be 350 and 35. Yeah, 385. So what do I know? I know x is 7. So what does that mean? There's 7 quarters. There's 14 dimes, because if x is 7, it's 14. And it's going to be, what, 14 plus 5 is going to be 19 dimes. Someone says, I wonder what their question is. Their question is, how many quarters are in the collection? The answer is going to be 7. All right, I want to just check it with the answer key, and I'm seeing it. There's 7 quarters. Let's go to number 2 now. Again, if this seems like it's going too quick for you, all I can say is, watch it off schedule, pause the tape, re-listen to it if you have to, go back over the notes. You need to start to study. All right. Then number 2. And I'll read it to you. It says 2 cyclists start from the same point and ride in opposite directions. So I'm going to say this reminds me of a distance rate times time problem, uniform motion. It says one cyclist is twice as fast as the other. In 3 hours, they're 81 miles apart. So I'm going to draw a picture. There's a starting line. There's 2 bike riders. They start from the same starting line, but they go in opposite directions. One guy's twice as fast as the other guy. So he's going to go twice as far. I'm going to write this down. I'm going to say D1, R1, T1. This is going to be D2. This is a slow guy, right? R2, T2. And again, we're not asking to memorize, we're asking to read. 2 cyclists start from the same point and ride in opposite direction. One cyclist rides twice as fast as the other. This means their rate. So if this guy is X, the other guy is twice X. It's twice as fast. It goes on to say in 3 hours. What does that mean? In 3 hours. So what do I get here? Distance equals rate times time. So what do I get over here? 3x. What do I get over here? Well, 2x times 3 is going to be 6x. Okay, so in 3 hours, what are they? It says they're 81 miles apart, which means the distance between them is 81 miles. Now, I hope you realize the distance between them is contributed by 2 things. The distance this guy goes and the distance this guy goes. So I have an equation now. 81 is going to be the slow guy's distance plus the fast guy's distance. I got my equation now. Let's see if we can solve it. 81, 3x and 6x is 9x. Divide both sides by 9. And what do you get? 9 equals X. Now, someone says, I wonder what the question is. The question says find the rate of each cyclist. Let's write this down. What's the rate of this guy over here? 9, because X is 9. What is it? Miles per hour. And what's this guy's rate over here? It's 2 times 9, which is 18 miles per hour. So what are the rates? 9 miles per hour and 18 miles per hour. I'm going to recommend check it in the answer key. What does the answer key say? 9 and 18. All right, let's go to the next one. Number 3. And number 3 says a silversmith mixes, well, I got a mixture problem. It's so typical. These are going to be very simplistic mixture problems. They're going to be 2 things. Now, are all mixtures so simple? No. I'm going to do what I've been doing in class, which is my little tiny boxes, and summarize what this mixture looks like. So it says the silversmith mixed 15 grams. I'll write this over here. 15 grams of an 80% silver alloy. I'll write this over here. And that's a silver alloy. I was going to say 80% silver. All right, I'm just reading. I'm not trying to memorize. A silversmith mixes 15 grams of an 80% silver alloy with 60 grams of a 25% silver alloy. And alloys are mixtures of metal. Okay, it goes on to say, what's the percent of the final mixture? So I'm going to write this over here, X percent silver. I hope you realize if you have 15 and 60, you'd have 75 grams. All right, let's write this down. And what do you get over here? Well, 80% is 80 over 100 times 15. I'm talking about silver now, plus 25 over 100 times 60 equals, I'm just looking at my box to write that down, X over 100 times 75. Well, I'm going to do a reduction here. And why do you do reductions? It makes it easier for me. That's the only reason I do it. So I'm going to say, the first term, I'm looking at this one over here, that would be 8/10 or 4/5. I'll do it in stages for you. And I'm noticing that 5 goes into 15 3 times. So this first term would just be 12. Let me do the next one. 25 over 100 is 1/4. And yes, you can use decimals if you want. 4 goes into 60 15 times. Well, that was convenient. Let's do this side over here. And I'm noticing that 75 and 100, well, they got 25 in common. So I'm going to say 3/4 of an X. Again, my goal is to come up with the X in the problem. Let's take a look at it. And 12 and 15 is going to be 27, right? I'm going to multiply both sides by the reciprocal of 3/4, which is going to be 4/3. I'll write that down for you. Well, on the right side, I get something really simple because the 3 and the 4 disappears. You just get an X, which is really what I want to know. On the left side, I want to point out what I'm getting over here. 3 goes into 3 once, and it goes into 27 9 times. What's 9 times 4? 36. So I now know the answer. And what's the answer going to be? 36%. All right. Do mistakes happen? Of course they do. That's why we're going to encourage you to look at the key. What does it say? 36%. Feel good about it. Let's go to number 4. Again, we're trying to reinforce what you've learned during lecture. What's number 4? Tickets for a school play sold for $7.50 for an adult, $3 for a child. The total receipts for 117 tickets sold was $693. Find the number of adult tickets. So I'm going to say A equals the number of adult tickets sold. I am going to say C is the number of children tickets sold. All right. By the way, I know they want A, but here, let me read it again to you. It says, the tickets for a school play, the adults cost $7.50 each. So these cost $7.50 each. And these cost $3 each. So each ticket is $3. All right. It says they sold 117 tickets. That means the number of adults plus the number of children tickets is 117. Well, I'm really kind of interested in, the A in the problem. So I'm going to solve this for C. And what's C? 117 minus A. All right, now what else do I know? I know they made some money. They made $693. Every adult ticket is worth $7.50. How many adult tickets they sell? A. Every child ticket is worth $3. How many children tickets do we say? You could say C, but I want to point out we want it in terms of A. And what's it going to be? 117 minus A. All right, let's go through the work. 693, 7.5A plus, let's see, that would be 330 and 21, 351 minus 3A, 693. 7.5 minus 3 is 4.5. A plus 351. I'm going to subtract 351 from both sides. And what do you get? You get 4.5A. I'm going to move this up a little tiny bit. Let's see, 2, 4, 3. I know this is difficult. I'm going to cleanse it. You can use calculator. I don't mind if you use calculator. I just want to go through some things you might have done in grade school. And I'm going to divide both sides by 4.5. And the right side's pretty, just A. As soon as I can't do that, I think you can. And what I'm going to do over here is just rewrite it for you. 342 over 4.5. I know in grade school they said they were moving the decimal. Really what they're doing is multiplying top and bottom by 10. And then we get 3420 over 45. All right, I'm going to do long division for you. Let's see. I'm going to say it goes in what? 7. 7 5 times 35. 28, 31. I'm going to subtract now. And what would you get over there? Well, let's see. 27, right? Well, that's a success story. Put a 0 there. Now it's 45 going to 27. Let's see. I'd say 6 times, right? 6 times 5 is 30. 24 and 3 is 27. So I got 76. All right. If you're looking at this and I don't think I could do that, you really need to start to practice arithmetic. But the bottom line is it's totally confusing to you. Please use a calculator. All right. But I'm going to say there's 76 adult tickets sold. All right. Let's look at the answer key, see how we did there. And they say 76. We did a great job. All right. Let's go to the next one, which is number 5. And what's number 5 say? It says silversmith combines, it's another mixture problem. And it's so typical. I can't say all mixtures are this typical, but we're at the beginning stages of mixing things together. 2 things, and we'll get a final mixture out of it. Okay, let's write that down. Silversmith combines pure silver that costs $16.50 $16.90 per ounce. So this is pure silver. And it's $16.90 per ounce. Okay. So he says, Socialist combines pure silver that costs $16.90 per ounce with 70 ounces of a silver alloy. I can write that down. So there's 70 ounces of not pure silver, but a silver alloy. All right, don't be alarmed, just reading. And they say this one over here costs $15.20 per ounce. Okay, and keep reading it. How many ounces of the pure silver? I don't know. I'll write this down. X ounces. I have no idea. How many ounces of pure silver were used to make an alloy of silver? Well, if you mix these together, it's still going to be a silver alloy in the end. All right. And they want to know how many ounces of pure silver were used to make a silver alloy that costs $16.20 per ounce. I'll write this over here. How many ounces do we have though? Well, I want to point this out to you. If we took X ounces here and we have 70 ounces here, it would be X plus 70. I'll write this down for you. All right, let's go to town. What do you get over here? 16.9 times X plus 15.2 times 70 equals 16.2 times X plus 70. All right. So I'm going to do the arithmetic for it. I want to point out, I'm going to pull out a calculator just to make sure you know. I'm hoping you're hearing this. I'm actually taking one of those dinosaur calculators, and I'm going to start to do some multiplications for you. I'm trying to encourage you to use technology too, by the way. Let's do this. On my calculator, got to turn it on. 15.2 times 70. Pretty easy to do. And what do you get? A nice number. You get 1,064. I have a tough time reading my screen. It's going dead on me. I think I did a good job over there. 16.2 X plus, well, I'm going to do 16.2 times 70 now. I get this number. Things are working out pretty nicely. Now what I'm going to do, I'll tell you what I'm going to do. I'm going to take 16.2x from both sides, and I'm going to take 1,064 from both sides. Well, if I did that, I don't think I need a calculator for that, but if you could use calculator if you want, that's going to give you 0.7x on the left side. That's not so bad. On the right side, what do you get? Well, you get 36, 34, 70. Now what I'm going to do, I'm going to divide both sides by 0.7. And what are you going to get here? And again, you're allowed to use calculators. X equals 100. All right. Now, before I do anything, I want to make sure you understand what their question was. You may have to reread it again. Their question is, how many ounces of the pure silver? Well, I know my answer now. What is it? 100 ounces. Let's look at our key. See how we did. And I'm looking at it, and lo and behold, they say 100 ounces. All right, let's go to number 6. I'm going to push this up. And I'll read it to you. It says, at noon, a train leaves D.C. for Charleston, South Carolina, a distance of 500 miles. So I'll put this down, like picture-wise. I'm going to put D.C. here. And I'm going to put South Carolina here. Okay? So again, it says at noon, a train leaves D.C. I'm going to write that down for you, 12 noon. All right, train leaves DC for Charleston, South Carolina. It means he's going towards South Carolina. A distance of 500 miles. I'm going to put the distance down for you. So the distance between these two is 500 miles. Okay. So again, just keep reading it. Do you understand what you've read? At noon, a train leaves Washington, D.C., headed for Charleston, South Carolina, a distance of 500 miles. I pretty much got that covered. The train travels at 60 miles per hour. Let me write this down now. D1. Let me go to black ink. You may wonder why I'm using D1. Well, the main reason is it's the first train you're talking about. There's going to be another one. R1, T1. Again, we want you to concentrate on the reading of it. So it says the train travels at 60 miles per hour. I'll put this over here. Okay. At 1 p.m., it's another story now, a second train leaves Charleston. So I'll put this down. At 1 p.m., a second train, I'll call this 2, a second train leaves Charleston for D.C., traveling at 50 miles per hour. Okay. How long after the second train leaves Charleston? I don't know. I'll read that again to you. How long after the second train leaves Charleston will the two trains pass each other? Well, I'm hoping you're starting to realize that this DC guy leaves first and he's faster. So if they're going to meet, they have to meet over here somewhere. You get the idea? All right, we're not trying to confuse you. It's important you understand what you've read, though. Here comes a problem now. I'm going to summarize every single letter in the problem, but I still don't have an equation. For example, the South Carolina, the second train, I can write its distance down. It's rate times time, so it's 50x. Now here comes the problem. The DC guy has been traveling for an hour longer. He left at 12 noon, so he's been on the track an hour longer. What does that mean? X plus 1. What goes over here? Rate times time, which is 60 times x plus 1. All right, you're still not there. You got to write an equation down. I want to tell you what the equation is going to be, though. The distance is 500 miles. The total distance is 500 miles. Where's it coming from? Again, I want to emphasize coming from over here. It's coming from this guy's distance, which is the DC guy's distance, and the South Carolina distance. What's going to cover 500 miles? Let's put that down. What's the DC guy's distance? 60 times x plus 1. And what's the South Carolina guy's distance? 50x. Let's write this down now. 60x, I'm expanding, plus 60 equals 50x. 500, 60 and 50 is 110, plus 60. I'm going to subtract 60 from both sides. I'm no longer thinking about the words in the problem. I'm thinking about solving a very simple equation. This is going to be 440 equals 110x. And then I'm going to divide both sides by 110. And what do you get? Well, pretty simple. You would get x equals 4. All right, so I know what x means. Well, I'm going to emphasize that it means something. So if x is 4, what does this mean? Well, if x is 4, 4 plus 1 is 5. It's time. It's 5 hours. What's this over here? Miles per hour. Again, if x is 4, this is going to be 4 plus 1, which is 5. 5 plus 60 is 300. It's distance, which is miles, right? Let's put this over here. This is going to be 4 hours. Miles per hour. And if x is 4, this would be 200 miles. Okay. What was your question? Right? You say, I can't remember the question. You go back and read it. It says, how long after the train leaves Charleston? Well, I know my answer now. It's 4 hours. Let's get a little pen out, see if we got it right. And I'm looking at my answer key, and we got that one right. I'm going to number 7. And what's number 7? Ferry leaves the harbor and travels to a resort island. A little picture down for you. Harbor, resort island. This is the island. This is the harbor. I know a boat leaves the harbor. So a ferry leaves the harbor, travels to a resort island at an average speed of 18 miles per hour. So I'm going to put this down. It's really kind of first thing I'm reading. So I'm going to say, distance 1, R1, T1. This is when he's leaving for the island, right? Again, we don't know the whole story. I haven't read it yet. So a ferry leaves the harbor, travels to a resort island, average speed of 18 miles per hour. That's its rate. It says on the return trip. Now I know return trip means he's going to go this direction here. So he goes to the island and comes back. I'll call this the second part of the trip. So yeah, you read it. It says, on the return trip, the ferry travels at an average speed of 10 miles per hour. All right. The total time is 7 hours, though. That's interesting. He goes there and comes back. It took him 7 hours. All right. Their question seems a little bit unusual to me, though. It says over here is, how far is the island from the harbor? They're actually asking for the distance. All right. Yes, I confused. I don't know what to do. Well, the key here is it took them 7 hours. So what I'm going to put over here, it took him 7 hours. Well, he had to take some of that time to get to the island. And then what's left over? 7 minus x to get back. All right, let me repeat that. If it took him x hours to get to the island, it took him 7 minus x hours to get back to the harbor. Now let's put our distance down now. What's it going to be? Rate times time, 18x here, and rate times time, which is 10 times 7 minus x. All right, so I don't know what to do now. Well, the key about this is the distance to the island is the same as the distance back. So their distances must be equal. Let me write that down for you. 18x, that's a distance to the island, is the same as the distance from the island back to the harbor. Let's see what we get over here. I'm not thinking about the words anymore. Get the idea what I did there? So we did, 18x equals 10 times 7 minus x. I multiplied it out. I'm going to add 10x to both sides. Now, it looks pretty nasty, right? That's 28x equals 70. I'm going to divide by 28. Don't be intimidated. I'll write this down. X equals, and what's that going to be? Well, let's see, 70 divided by 28. I could divide by 7, right? So I would get 10, because, 7 goes into 70 10 times, and 7 goes to 24 times, right? And 10 divided by 4 is going to be 5 halves, isn't it? And 5 halves is 2.5. Now, someone says, I wonder what that means. Well, I hope you realize this is 2.5 hours. This is 18 miles per hour. Well, let's see. Can we do 18 times 2.5? That would be 36 plus 9, which is 45 miles. Let me just briefly go through this with you. 7 minus x, right, would be 4.5 hours, 10 miles per hour. Well, 7 minus 2.5 is 4.5. And what's 10 times 4.5? 45 miles. Let's see what their question was. Their question is, how far is the island from the harbor? Clearly, it's 45 miles. Let's get our key out, see if they say that. And they did, 45 miles. Let's go to number 8. And I'll read it to you. It says, rubbing alcohols typically dilute water. Well, sounds like a mixture problem. And it's so typical at Essex that a mixture is going to be two things mixed together. to make some final mixture. I'll read it to you. Maybe I'm confused, but I'll try to read it to you. Rubbing alcohol is typically diluted with water to 70% strength. If you need 4.2 ounces of 45% rubbing alcohol, I'm going to write this down for you. You need 4.2 ounces. You need it of 45% alcohol. That's what you need. It says how many ounces of 70%, I'll write this over here, alcohol. How many ounces? I don't know. If you need 4.2 ounces of 45% rubbing alcohol, how many ounces of 70% rubbing alcohol and how much water? Well, here's the problem. It's 0% water. Alcohol, I'm sorry. All right. Let's see if you can write this down. And what's going to be? It's going to be, the ounce is going to be 4.2 minus X ounces. All right, and repeat what we said over here. We want 4.2 ounces of 45% alcohol. How many ounces of 70%? I don't know. Must be mixed with water. Water has no alcohol, so I said 0% alcohol. And what's the number of ounces? 4.2 minus X. All right, why is that? If you add this to this, you get 4.2. Let's write our equation down. 0%, 70% equals 45% times 4.2. Well, the zero is easy, right? It would just be 0. And then you get 0.7x. I'm going to do it on a computer. And what I mean by the handheld calculator, I'm not going to take 4.45 times 4.2. And I get 1.89. I'm going to divide both sides by 0.7. And what do you get? Well, the left side's easy. You can divide that 1.89 by 0.7. And what do you get? You get 2. My calculator's really hard to read, by the way. 2.7. So I want to make sure you understand what their question was. And their question is how many ounces of 7%? I know it now. It's 2.7 ounces. I can put this in a box. And I'm going to get my key and to look at it. And what does it say? It says, oh, by the way, I'm sorry. There's also another question there. It says how much water should you use as well? So I didn't answer the question completely. So 2.5 ounces of the 70% alcohol. And they want to know the water. That's OZ. And that's going to be 4.2 minus 2.7. And that would be 1.5. And this is the water. Okay. This is the 70% alcohol. All right, get my pen out again. 1.5, let's see. Yeah, 4.2. Let's take a look at it. 2.7. We got this right of the alcohol and 1.5 ounces of water. Looking great. All right, let's go to number 9. And number 9 is, let's take a look. I know it's tough. It's another distance problem. After a sailboat is on water for 3 hours, a change in the direction reduced the average speed of the boat by 5 miles per hour. The entire distance sailed was 57 miles. Let me put this over here. Entire distance. Okay. After a sailboat was on the water for 3 hours. This is the first part of the trip, by the way. First part. So after the sailboat was on the water for 3 hours, right? Something happens. The wind changes. It slows the boat down. Okay. So again, after a sailboat has been on the water for 3 hours, a change in wind direction reduced the average speedboat by 5. Well, I'm going to say if this is X, his speed's been reduced by 5 miles per hour. The entire distance sailed was 57 miles. The total time spent sailing was 6 hours. So if the first part of the trip was 3 hours and the total trip was, 6 hours, the second part of the trip had to have been 3. Well, let's summarize now. So, first thing you're going to do is, write down distance here, write down distance there, and then let's see if we get an equation. What do you get over here? Rate times time, rate times time. Okay? So I want to point out, the first part of the trip, he's going along at a pretty good clip, covers most of the distance. Then the wind changes, and he continues on. Second part. What do I know? I know the distance from the first part plus the distance from the second part has to cover all 57 miles. Oops. All right, got my equation. 3x plus 3x minus 15 equals 57. I'm not thinking about the words anymore. 6x minus 15 equals 57. I'm going to add 15 to both sides. We're hoping you're getting more comfortable solving equations. And what would that give you? Let's see, 67, 72, right? Make sure I did that right. Yeah, 72. And x, oh boy, that goes in a nice number of times, doesn't it? 12 times. I don't even know what that means. Well, it means something to me. X means 12. So that means the rate. It's 12 miles per hour. What's this one over here? Well, 12 minus 5 is 7 miles per hour. This is hours. This is hours. I'll get to the question later. 3 times 12 is 36 miles, right? And what's this one going to be? 3 times 7, which is 21 miles. 21 and 36 is 57. What was their question, though? Their question was, how far did the sailboat travel in the first 3 hours? What's the answer? Well, it's right over here. So it's 36 miles. All right, let's get my little answer key and look at it, and certainly we're in agreement with that. I feel good about that. Let's go to number 10. And what's number 10? The stamp collection. Well, I got 3 cents, 12 cents, 15 cents. It's still a mixture problem. A little more interesting mixture problem, by the way, but kind of basic mixture problems. The number of 3-cent stamps is 5 times the number. Oh, got numbers of stamps over here. Let's write this down. So the number of 3-cent stamps, the number of 12-cent stamps, the number of 15-cent stamps. And again, I want to go back and read it to you. I'm not trying to memorize. It says the number of 3-cent stamps, the number of 3-cent stamps is 5 times the number of 12-cent stamps. Well, I'm going to say I don't know what that is. That's how many 12-cent stamps, there's X of them. So again, the number of 3-cent stamps is 5 times that number. I'm going to keep reading it to you. The number of 15-cent stamps is 3 less. It's 3 less than the number of 12-cent stamps. Okay? The total value of the stamps is $2.49. Let's write that down. $2.49 is the total value. Well, here's the deal. We have 3-cent stamps, right? They're worth 3 cents. How many are there? 5x. There's also 12-cent stamps. Well, they're worth 12 cents. How many are there? There's X of them. Plus, move this over a little bit. There's 15-cent stamps. They're worth 15 cents. How many are there? X minus 3. So $2.49. Oh boy, that's going to be 0.15x. Yes, you're allowed to use calculators. Plus 0.12x plus 0.15x minus 0.45. I got to keep going. 249. Let's see, that would give me 42, right? So 42 That's 0.42, by the way. Minus 0.45. I am going to add 0.45 to both sides. And what do you get there? 0.42x. Again, I want to repeat, I'm not really thinking about the words anymore. I'm thinking about solving a very simple equation. And what do you get over there? Let's see, 54, 94. So it's going to be 294. I am now going to divide both sides by 0.42, the coefficient on x. And what do you get for x? Should be easy, by the way. But again, you're allowed to use calculators. And I'm going to say, like, let's see, what is it? 42. I'm going to say 7. Let me see if that's right. 280 and 14. Yeah, that's right. All right. So what was the question? Go back and read it. And it says, find the number of 15-cent stamps. Well, I'm going to write this down for you. There's x, which is 7. 7 minus 2 would be 4. So there's going to be 4 stamps. 4 of these things. 4 15-cent stamps. So 4 stamps. And we're talking about the 15-cent stamps. 15-cent stamps. Let's look at the key, see if we got it right. And they say it. We're feeling good about that. All right. Again, we're not trying to confuse you. What about if you are confused, like, you know, when you're putting a lot of time and effort into this, please come by to our website. I'll be more than happy to help you. So what's number 11? How many quarts of water must be added to 9 quarts of 80% antifreeze? Wow, another mixture problem. And let's put it down. So what do you got over here? How many quarts of water? I don't know. This is water. I'll put down X quarts. Must be mixed with 9 quarts of an 80% antifreeze to make a 45% antifreeze. Okay. Now I want to point out to you, if it's water, it's 0% antifreeze. All right. How many quarts do we have in the final mixture, though? Well, there'll be X quarts of water and 9 quarts of that 80% model. All right. Let's write this down. 0 times X plus 80% times 9 equals 45% of X plus 9. All right, pretty easy, right? So what do you get? 7.2, 0.45X plus, well, I'm going to do 9 times 45, right? I'll write this on the side for you so it can be done. 9 times 5 is 45. 9 times 4 is 36. 36 and 4 is 40. So it's going to be 4.05. All right, let's keep going. What am I going to do now? I'm going to subtract 4.05 from both sides. All right, let's write down what you get. Again, if the arithmetic's really frightening you, please use a calculator. So 7.2 minus 4.5, what's that going to be? I guess 315. Now I'm going to divide both sides by 0.45. My pen seems to be running out of ink, by the way. And just give me a second. I hope it didn't die on me. Nope, there it goes. What do you get there? X. And let's see, it goes in, let's see. I guess 7 times, right? Let's say 280 and 35. Yeah, 7 times. All right, I got that answer. And the question is, I know what X is, but I wonder what their question was. And their question was, how many quarts of of water did I use? Right, I use 7 quarts. Oops, that's not a G, that's a Q, right? All right, let's get a little answer key. See if that's what they said. Yeah, they said it. Feeling good about that. Let's go to 12. And 12 is our last word problem. I know it's exhausting for students, by the way. We're trying to encourage you work, though. You're not going to become educated unless you do work at this. Passenger train leaves a train station. A train depot is like a train station. 2 hours after a freight train, blah, 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 blah. I think we've seen something like this before. 2 trains leaving, one before the other. It's going to be a catch-up problem. All right. So a passenger train leaves a train depot 2 hours after a freight train. So I'm going to just call it top guy freight train. And I'm going to call this the passenger train. Who left first? The freight train. I'm going to call D1. T1 and R1. Oh, you know what? I'm always putting this sense in. I apologize. I got to go back and erase that because I want to confuse you with the order of things. I'm always doing the same thing. Distance, rate, time. Sorry about that. And this guy over here, I'm going to call it, distance 2, rate 2, time 2. Again, I'm not trying to memorize, I'm trying to read. Passenger train leaves a train depot 2 hours after the freight train leaves the same depot. The freight train is traveling 20 miles per hour slower than the passenger train. This is concrete information now. 20 miles per hour slower. I got that car covered. Find the rate of each train if the passenger train, Find the rate of each train if the passenger train overtakes the freight train in 3 hours. Okay. So I don't remember what I read. Well, the freight train was given a 2-hour head start. If he's given a 2-hour head start, that means he's been traveling for 5 hours when this occurred. Overtake means when they meet up, by the way. Let's summarize. Distance equals rate times time. Distance equals rate times time. What do I know? Their distances have got to be equal. Let's put this down. I'm no longer thinking now. So 5 times x minus 20 equals 3x. 5x minus 100 equals 3x. I'm going to subtract 5x from both sides. And you get minus 100 minus 2x. I'm going to divide both sides by minus 2. I'm no longer thinking about the words in the problem. I'm thinking about what x is. Well, x appears to be 50. What was our question now? It says find the rate of each train. I think I know it now. The rate of this train is 50 miles per hour, and the rate of this train is 30 miles per hour. So the rates are going to be 50 miles per hour and 30 miles per hour. Put this in a box, look at the answer key, and I got it. I'm feeling good about that. All right, let me briefly go to Sage. And I'm just going to do a switcheroo on the screens. And I'll do this. Let me get this over here. So we just finished problem number 12. And again, I'm not really, I'm not trying to confuse you guys with the Sage code. Our hope is this, though, that you're starting to pay some attention to the opportunities that are availing themselves to you. And one of the opportunities may be computer coding. At least learning it might be helpful. It might be helpful. So I'm going to, launch that my Sage thing again. And what I mean by that is I want to point out, you can click on the link if you like. Maybe I should do that for you right here. You'll go to Sage. All right, I want to point out in Sage, you go to the CoCalc thing. We've done this many times before. CoCalc will launch. Oh, I was there 55 minutes ago. Let's not worry about that. At this point, you should have an account. You should know about creating a new document. What kind of document? Sage worksheet. I'll type this code in. This is code. You're going to learn from it. What does reset do? It kind of clears the memories out if you have anything left over. Remember this though, if you're using the web-based version of this, you must hit the shift key first, then the return. It's going to execute it. Then I'm going to type in NDQ. I think this reminds me of a problem that we've done before where N is the number of dimes, D was the number of N is the number of nickels, D is the number of dimes, Q is the number of quarters. These are variables. And I'm going to write this down, N, D, and Q. Remember, shift, return. It's going to execute the command then. So I'm going to put equation 1 down. This is something new. We haven't seen this before. Equation 1, EQ1. No, we're not actually memorize. We're trying to say that this might be useful though. And what is equation 1? It's an equation where D is equal to 2 times Q. Remember this, shift, return. All right, let me put down equation number 2 now. Equation 2 is being assigned, it's a single equal sign, an equation, that equation is N equals D plus 5. I'm going to hit shift, return now. And I did that. And now I'm going to put down equation 3. Equation 3, EQ3 is 0.25 times Q plus 0.10 star D plus 0.05 star N equals 4.1. Shift, return. Let me go through this with you. Reset, clear out the memory, start a fresh page, like opening a notebook, opening up to a new page. N, D, and Q are variables. That's all we said over here. Equation 1 is where D is twice the number of quarters. Equation number 2 says the number of nickels is 5 more than the number of dimes. Over here, which is a value equation, it says 25 cents. That's what every Q is worth. The dimes are worth 10 cents and nickels are worth 5 cents. And we have a total of $4.10. All right, here comes a tough one. We want to solve an equation. Again, I'm not saying we're at this level yet. We're going to solve. What equation are we going to solve? 3 together at one time. I know this looks very strange here. You're going to get your feet wet. As you get your feet wet, you're going to become more comfortable entering this water. So it's equation 1. All right, I'll put this down, EQ1. I also want to present EQ2 to it. And I also want to present to it EQ3. Now what it's going to do is take all those 3 equations at the same time, and it's going to work on solving them. But I got to tell you what to solve for. I want to solve for not only N, but I want to solve for D and Q at the same time. Now, granted, I make mistakes a lot. I type wrong. I put the wrong stuff down. You're going to do that too. Part of that is just learning. Let's put that down. I hit the shift, return again. And it works out. It says N is 19. There's 19 nickels. There's 14 dimes and 7 quarters. Let me repeat this. You're never going to get to this stage of being able to code unless you can do simple things by hand first. Most coding comes with, I'm going to write something down simple and then work on it. All right. And I'm going to say, hopefully you can think about what we just did. We're getting a little more complex in the coding, but you're learning something. The coding is related to the algebra that we're doing. All right. Good luck. Whoops, sorry about that.